All right, so today we have one item in the agenda, which is to show you a very simple machine learning problem and how do you solve that problem, especially how do you solve that problem with programming, specifically with Python. All right, so last time I did some quick introduction. We start with talking about the principles behind how we build a large language model. We need a lot of data. We need to clean up the data. And then most important step is to train a model that can learn the patterns from that data set. And that language model, what it does is that it takes the input of a certain string, a sequence of words, and then it trying to give an output on predicting what the next word should be. So that is a trained machine model. So I was trying to explain how the machine learning works. Some of you took the courses, some of you haven't, but it is very important technique everyone should probably know more or less today. It is a very complicated topic, but to apply machine learning, to just do some training, it's not that difficult. So I did give you some kind of background information last time on why, when did this happen, why people start to focus on AI, how this one being applied in different fields. I give you three examples. We start from the simplest tic-tac-toe to the chess example and all the way to the latest example, which is the AI program to play Go. And I had to explain to you that the Go is way more complicated than the other two games. That's why you cannot use the brute force as we did before. Okay, brute force is not efficient, but it's very effective. Okay, and you go to the scale of Go, a game like Go, it's not gonna work. So what people did from the Go game is that they use all this historical gameplays and then they try to train and that machine to learn all the patterns and techniques and strategies from it. Okay, so that process, that technique is called machine learning. Okay, so obviously Go is a very complex example. Okay, let's just start from something really simple. Okay, so normally I like to use this example because it shows the concept really good. So I will, let me actually do this. So since we're talking about traffic, okay, I probably just will use a traffic example. We're gonna use something to maybe one thing very related to us is to predict the traffic. Okay, to predict how much traffic. This is not a new feature. You know, I don't know how many of you have used um, Google Map that you could actually get estimated time, right, on how long it's gonna take from uh, A to B. So this is the real time, and then the really cool and helpful thing is that they can predict the traffic status, and this is pretty accurate. And but one thing they can also do is instead of saying I'm gonna leave right now, I will actually leave at a certain time, maybe in the future, right? So I will go, maybe I want to go on a Monday morning. I want to see what the situation looks like. All right. So it turned out that 7:30 from Monday morning, not bad. Oh, by the way, the Monday morning is a holiday. What if we try to change to a different Monday? All right, as you can see, this is really a cool example. You can see this time the prediction is a lot longer. It's up to 1 hour, 40 minutes. But then if you do next Monday because it's a holiday, and then this one, there's literally no traffic on 7:30, right? So they're pretty intelligent. Okay, so, but this is in the future, right? How could Google know that? Well, they are making a prediction. They are making a prediction based on the model they have, and then that model was built also in the same way by collecting a lot of data. So right here, let's actually try to get a very simple version of this problem that what if we want to, um, predict something. In this case, we want to predict the traffic. Okay, I'm going to simplify the problem a little bit. We just say that traffic from 1 to 10, 10 is the best, the worst, and then 1 is the best. Okay, so whenever you touch a machine learning problem, you need to first identify what are you trying to predict? What is the goal? What is the output? It's a next possible word. It's like a game to recommend, or in this case, it's some kind of indication of a value on how bad the traffic is, right? So first of all, identify your goal. And normally, you should just predict one thing each time, and in order to make the model more accurate and more straightforward. Okay, so that's the step one. Now, once you know what you're trying to predict, okay, The next thing to do is that you need to analyze and decide something called input features or input factors. So basically, the things or factors that will affect this traffic. Okay. So that input features could be multiple. And I think in general, if you can consider more features, more comprehensive features, that's normally help for the prediction problem. Okay. For example, in this case, can anyone tell me, give me some answers? Like, what are the factor or features could affect the traffic? So, for example, we look at that holiday thing, right? And if it's a holiday, well, obviously the pattern is a little bit different. At least in the early morning, you're not going to see a lot of traffic, right? But during the holidays, normally around noon time, maybe the traffic is worse, right? So one of the features is going to be whether it's a holiday or not, right? So that's going to be yes or no. Okay, that's one example. Could you guys give me some other features that could affect traffic? You can just type it in the chat. Yes. All right. If there are accident happening, obviously the traffic got bad. What else? Rush hours. Weather. Very good. The rush hours, to make it more specific, is basically time, right? Time of the day. Okay. Weather. Very important. All right. Anything else? One more. Mm-hmm. Constructions. Very good. Um, or I think another thing similar to holiday is the day of the week, right? Um, Weekdays, weekends, very different, right? So yeah, there are a lot more things. Okay, so we're gonna just this is enough, good for now. Okay, so but you can, as I mentioned, if you want to do more comprehensive analysis about the problem, getting more features normally helps, but not always. Okay, sometimes you have something called overfitting, so you got too many features, you actually complicate the problem. Okay, but that's the second step. All right. So now you have a very clear definition about a problem, about the machine learning problem you're trying to do. Okay. You know these are the things that's going to affect the results. Now, what machine learning you're trying to do, or in other words, what the model will try to do is that given this at the input, how do I generate the output on this one? It's almost like a function or it's a formula. Okay. You give all this input number and we're just going to generate the output number. So how can we do this? Okay, it sounds very straightforward, but that process is very complicated. Okay, using the approach of machine learning, what you want to do first is that you need to provide some existing data. You want to show me the history. You want to show me the games you played. You want to show me all the traffic status from different days, from different times. Give me some samples. That's how I can learn, I can generate the pattern. Okay, so once you have a definition about the problem, the first thing you need to do is to give some specific sample data as examples. All right, so that's the very first thing you got to do. Okay, so I'm going to start from the time because that's probably the thing that affects your traffic most, right? That's the easiest factor to think about. So I'm going to start from this one, and then to do any kind of sophisticated machine learning, okay, as I mentioned, just give some facts. Okay, so let's say I'm gonna start from 6 o'clock. Okay, 6 a.m. in the day, pretty good traffic. In LA, not always good. It's already people started driving, but still much better than the other. So I'm gonna give a traffic maybe 1 to 10. I'll give it 2. All right. Then as time goes, 7 a.m. and it definitely started to pick up a lot of traffic already, but still not the worst, right? You got a 4. And let's say for 8 o'clock, it's already very bad, and then I'm gonna give a 6. All right. And let's just say that in 9 o'clock. I think 8 already pretty bad, but 9 probably is even worse. Okay, so already getting 8. Something like this. Okay. Just assume that These are the things I observed, I measured. Okay, over the time, these are my experiences. Okay, but this is not a prediction. Okay, this is just the given facts and numbers. Once again, if you don't provide any data, there's no way for machine to figure out a pattern. Okay, so data is so important. Okay, so based on these facts, and then let me ask you this: if I only give you this four time slot, if I'm asking you what the traffic will be is going to be for 10 o'clock, um, how are you going to tell me or predict that based on the data I gave? How would you predict the traffic for 10 o'clock? Anyone, you can type me an answer in the chat. Yeah. So car is at 10, right? So obviously, the reason you said 10 because you pretty much see a pattern here, right? So as the hour increases, the traffic also increases. And then the nice thing is that it increases, equally. And then you can pretty easily figure out a pattern. And obviously, I put the data so that it's very clear to show the pattern, but the reality maybe is a little bit different, right? So, so I think that's correct. Okay, that's how you actually. We didn't tell you what the traffic at 10 o'clock, but we told you what happened before, and you are trying to make a prediction. And you might argue, well, 10 is not the busiest time for my area, maybe, but it doesn't matter because what the data tells you, it looks like that's the truth. Okay, so as you are making that prediction for 10, you are actually doing the work of a machine learning model. Okay, so that's the whole process. But from the algorithm or from a serial point of view, how did this one work? Okay, I'll give you a better way of explaining this one. Okay, so I am going to draw a mass function view, our axis, to represent the problem we're talking about today. Okay, all right. So this one here is the time. All right, and then here is traffic. And then based on the numbers we provided, let's actually first show all this time here in the axis. Okay, 6, 7, 8, 9. Okay, so you will have here, let's see, this is the 6, 7, and 8 o'clock, 9 o'clock. And here you got a 2, 4, 6, and 8. Okay, so as we are plotting all these data points, so you could very quickly put those into the axis. So 6 o'clock is 2 traffic, and then 7 o'clock is 4, and 8 it goes up to 6, and 9 goes up to 8. All right, so that's the data we provided. And then I was asking you guys, what is the traffic for 10 o'clock? Okay, and then Carol told me it's 10. All right, we all agree that that looks reasonable. But remember, we never told you what's the real traffic intent. You don't know that. Okay, it's just a prediction. Okay. But I'm trying to explain why are we predicting the data to be here? Because we saw a pattern. Okay. Based on the facts you told me, I can summarize the pattern so that I know the next one will be 10. But obviously, when I've been showing this one as an axis like this, you can probably know how to summarize it in a more formal or accurate way, which is, can I actually turn this into a function? Because looks at all these points, they form a function. And I'm sure that all of you guys have learned this one before, right? How do you describe this function? Give me an answer in the chat. Yeah, linear, but how do you write the formula? That should be a, I don't know, middle school or high school thing. Like how do you write the formula? Yes, yes. Mx plus b, right? I assume this one, yeah, you probably forgot. Okay, don't forget. It's very basic stuff. Okay, that's how you describe this function, this straight line. Okay, because when we see the data goes linearly, incremental. Now we're gonna assume that this is a linear situation, so we're gonna use a linear function to represent this pattern. You know, the nice thing about this one, guys, is that if you have this formula and you precisely just define the problem, and especially if you know what M and B is, then I give you any kind of X, you can accurately tell me what the value for Y. Okay? So I give you a little bit more, not challenging, but can anyone tell me what is M and B based on the data we provided here? Okay, do some quick math. Okay, what is M? What is B? How do you calculate? I told you this point. Okay, 6 and 2, 7, 4, 8, 6, and 9 and 8. So based on this given input, could you guys tell me the M and B? I gave you 1 minute. Okay, anyone got it? All right, 2 and 2. Okay, is that correct? Let's see. So no, I don't think that's correct because 6, right? 6 that's 14. That's not right. This shouldn't be right. Try again. 2 and minus 10. That sounds right. Okay, so 6 is 12 minus 10 2. Very good. If it's 9, it's 18 minus 10. Yeah, that's correct. So M is 2 and B is 10. Negative 10. Okay, very good. All right, good job, Blake. All right. So just a simple math stuff. Okay, nothing really special. You guys already learned that before. Okay, but now if we have this very concrete function like this, now we can predict any time, right? So you asked me about 10 o'clock. Okay, so I put 10 here, and that gave me a 10. So then I will know that's why this one is here. And then if I'm asking you the 11 o'clock, easy. All I need to do is put 11 here. Okay, and that gives you a 12. All right. See, now you got as a function, you can predict any time, any data in the future, or even the data you never know. For example, I want to know like 8.30, so 8.5, and then very quick you can get it. It's a 7. All right. So once you have this, guys, okay, you have a function and you figure out the parameters. Okay, this is actually called a machine learning model. Okay, because now this model can take any input and produce the output in a very defined and specific way. There won't be any kind of confusion or, you know, uncertainty. It's going to be determined, okay, to give you that answer based on the model you produced. Okay, so even though you feel like machine learning sounds like a very sophisticated topic, but this is the fundamental. Any kind of machine learning problem is just like this. So I give you a lot of data. Somehow you gotta give me a formula, but obviously a lot of time the formula is way more complicated than this one. That I got that formula, I can reuse it again and again with all the other kind of inputs. All right. So that's how it works. However, in reality, the data may not be this perfect because I was asking you M and B and took you guys about 1.5 minutes to tell me the M and B number, right? You guys did some calculation. But sometimes the number are maybe like this. Let's say that 7 o'clock is not exactly four, it's actually five. And then 8 o'clock is like a seven, and 9 o'clock is actually very high, it's like 10. Okay. And you look at the trend, it's still kind of increasing, right? So if you still want to summarize the model like that, and you might want to adjust the line a little bit. Okay, somehow like this. So I don't know if you ever learned something called a best fitting. So because it's not perfectly aligned like it's previously, you cover all the 4 points. Now you're just trying to get a best fitting line that can be as close as you can to all the points. You don't want to have something like too off, too much away, right? So in this case, I don't know how many of you know how to calculate the best fitting line for this. And obviously the M and B is not going to be 2 and negative 10. It's going to be different. Okay. Does anyone know? You don't have to tell me answer. I don't think you can calculate it, but does anyone know what approach to use to calculate MB for the best fitting situation like this? Have you ever learned that before? Anyone? Yeah. And among first of all, I don't know the answer. Okay, but I feel it's something about calculus. Yeah, gradient, those kind of things. All right. Yeah, anyway, so you can probably find out the answer. But that's not an easy thing. Okay, it's not as easy as the previous case that you can just look at the data and calculate, get the parameters. Okay, pretty complicated. And honestly, this one only had 4 points. And in reality, there could be hundreds, thousands, tens of thousands of points. And there could be multiple dimensions. It's not going to be 2D. It could be 3D. It could be 4D. And then if I still want you to do this kind of best fitting line, that's going to get way more complicated. Okay. So in practice, we're never going to ask you to manually calculate M and B. We do that with programming. Okay. So now let me just show you how do you use Python to actually solve this problem, a machine learning problem like this. As a very basic, very simple linear regression problem. Okay. By the way, this best fitting line, finding a best fitting line to cover all these points to predict the future, that process is called a regression. Okay. We believe it's linear, and so that's called a linear regression. All right. So this is how you're going to do in Python. Okay. This whole algorithm of getting M and B is very complicated. We don't expect you to write that code. So we use libraries, and the most famous library here is called scikit-learn. Okay, or sometimes people call it sklearn. Okay. To do this program, pretty simple. Okay, I'm going to write this code for you right now. First of all, you got to prepare all the data set. Okay. Remember, we already defined a problem. These are the input, these are the output. Right now, we're only talking about one input, which is time, right? So I'm going to call this one as the input data. Okay. And I provide a list because you have different rows. Okay. That's why you need a list. And every row, I'm going to use another list because later on you might have multiple features. So it's better to group all of them into another list. But right now it's just one. So I'm just going to put one. So 6 o'clock, 7 o'clock, and 8 o'clock, and 9. All right. So there are 4 rows, 4 inches. That's how we do this input data part. We also have output data. All right. So that's 2, 4, 6, 8. Very simple. All right. So we write this way. So these are just getting us the data set to the program so that we're ready to read and load and to process. Okay, that's the first step. All right, and then after that, well, you got to decide which model you're going to use. Now, in our case, we have decided this one going to use a linear model. More specifically, we call the linear regression. Okay, let me write it down. All right. So that's the model we're going to choose. So sklearn, that library, they have all these models for you. Now, in this case, we don't have that model. So let's actually see if I can just get that dependency. All right. We're going to import something called a linear model. Okay, it's all coming from this library. Okay, just the import statement. And then once we have the import statement, we can then define our first model, which is called a linear regression. Wait, I think it's called a linear model. Yes. Okay, use the reference. Okay, I just like create object. I'm going to use this model. All right. Now, once you have a model, then we're going to tell the model that, okay, we believe this problem is following linear regression. Now, here are my data set. Please take the data set and learn and train the model. So then what you do is called a model dot fit. Okay, fit is just like best fitting. It's a simple term to talk about the process of learning and training. It means the same thing. You can also understand that the training. Okay. So as you try to fit or train or learn, you got to provide both data because without the data, there's nothing to learn about. Okay. So you provide input data, output data, and then you finish the training. And after that, your model is done. So let's try to run this code. So I'm going to run this. All right. So it looks like this is working. Okay. Just some kind of version conflict stuff. Okay. So that's the pain part about the Python. I think the better practice is to use the virtual environment. But anyway, so we got the data, we import a model, and we decide to use the model, we train the model. Okay. But now how are we going to predict? So there's something called a model dot predict. Okay. When you predict, all you need to do is provide that input, okay, in the same kind of format. For example, I'm going to use call and to predict for 10 o'clock. And in this case, you need to wrap this one into another list because sometimes you could predict for multiple records, right? So you predict for 10 and I can got the results and then print the results. Okay, so let's run the code. So for 10 o'clock, the traffic we predict it to be 10. And you can try more. Okay, I want to see 8:30. I want to see 12 o'clock. And I want to see 15 o'clock, 15, 3 p.m. And you run this one, and they can give you all the results. As you can see, 8:30, it is 7, and then that's 14, that's 20. Basically, just keep increasing. All right. So that's how the programming works for machine learning model. So in this case, you don't need to worry about how do you get the MMB, how do you get the best fitting line, and all is done by the program. And you can retest it. For example, this is not a 2, like 2.5. This is 5.1, this is 6.9, and this is 9.9. Okay, we'll make it very complicated. This is very difficult for you yourself to calculate like this, right? So, but it doesn't matter if we run this code and we'll get the results. Okay, for 10, this times 12, that's 8.5. It looks very straightforward. All right. So that is called machine learning, guys. Even though we know machine learning and AI is pretty sophisticated, but I want you to always remember this little example using linear regression. I know it's very simple, but it clearly shows the steps of running or solving a machine learning problem. One more time to recap. Um, you need to, first of all, define a problem by knowing what's the output, what the related input parameters. And step two, you need to fill in some sample data, give some facts for machine to learn. And then next step is that you can then choose a model, okay, and put the data there and then trigger the training process. Once you train the model, you can then predict all the results. Okay, so that's how machine learning works. Any kind of machine learning problem always follow this one. Like I told you before about the large language model. Okay, so you still do the same thing. Okay, you identify what's the output, what's the input, you provide a lot of data, you choose the algorithm, and you train it. And it's all the same thing. All right. So that's a very simple example, but see how simple the code is. It's literally just one, two, three, four, five, six. Six line of code you can use a machine learning to do something. Okay, so the library here are very powerful. Now in the future, when you are handling more complicated problems, the difference will be the data will have more things. You will need to import a different kind of model. That fitting process is going to take longer, and yeah, the result will be a little bit different. Okay, but fundamentals are exactly the same thing. So hopefully that gives you some kind of insights. I want to move a little bit further because as you may know, the traffic, okay, obviously is not just a linear because we all have experiences probably, okay, around at 10 o'clock, as you get to after 9, when you get to 10, I think the number will drop back, right? And the 11 will be a lot easier, and 12, maybe you don't really have that much traffic. It's something like this. That's probably what happened for reality. But from the machine learning problem, okay, if we didn't tell you that data, if we didn't tell you it's going to drop, there is no way for machine to know it's going to be drop. Okay, so that's why the data is so important. Okay, obviously for traffic, you guys have your personal experience. You will know this problem more or less, but a lot of problems you just can't know those. Okay, you really have to rely on the data 100%. Okay, so let's say if we give you more data, 10, 11, 12. As I mentioned, 10 goes to 7, and 11 go to 4, and 12 go to like 2, something like this. All right. Then how are you going to predict? Now, if you use this approach, I'm going to provide those at 10, 11, 12. So I give three more data point. And here, like that's 10. 10, I'm going to drop like 7, and then it's 4 and 2. Okay, just kind of a curve kind of shape. So I add a little bit more data. All right. So now let me make some prediction. I still want to predict 10, 8, 5, and 12 and 3 p.m., right? So remember this was the data before. But now if I try to run this, okay, see, it's getting different. So 10 is 5.2, 5.4, 4.9, 4.5. See, they're not that a big difference. Okay. For 10, especially for 10 o'clock, the reality is actually 7, but you predict to be 5.2. For 8:30, it's this one is okay, but for 12 o'clock, you predict to be 5, but in reality, it's actually only 2. Right? As you can see now, when you look at these results, it's not that good. Hopefully, you guys can see the reason behind it. So if we are having the data like this, okay, we give the data like this. Well, we talk about if you're doing the linear regression, which is to find the best fitting line, how the line will look like, right? So it's probably something like this, best fitting. Remember the best fitting is a line that close to every point as much as we can. In other words, the distance between every point to the line, the sum is the minimum. Okay, so that is a best fitting problem. Okay, we're trying to do. That's why the line will become like this. That's why when you predict all the data, they're all pretty much follow and in the same kind of area. Okay, so it doesn't matter what data you provided, the machine learning model will always be able to figure out that parameter for you to use. But clearly, this is not very accurate, right? So when it's not accurate, then you got to figure out what's wrong with it. Now, in our case, obviously the model we choose is not good because this is no longer a linear problem. If you still use the linear problem, then that's not good, right? So now we need to change our model. Instead of using linear model, we need to use some of the polynomial model. Okay. In other words, we're gonna do a curve, something like this. If we can form a model like this, I think that clearly shows the problem much better, right? Does anyone know how to write this one? What's the formula here to describe a curve? What is the formula here? Oh, sorry. You guys can't see my screen anymore? Can anyone see my screen? Okay. Some of you mentioned you can't see the screen. Okay, let me reshare it, okay? All right. So the question here is that if we're trying to do a curve, okay, like this, how are you going to describe that function? Okay, yeah, very good. So, all right, looks like yeah, Blake, looks like your math is pretty good, right? Okay, it's like this. All right. So hopefully you remember. So this time the problem a little bit more complicated. We got to figure out A and B and C, right? So what are those? Once you figure out those out, then you can give any X and then calculate the Y. Once again, I can't remember how to do this. Okay, it's not that easy. So we'll let the machine to do it. Now in this case, the data remains the same, but the model we gotta change. So we're gonna use a polynomial model to handle this. Okay, so honestly, that part I actually forgot to code. I haven't done that for a while. So I'm gonna go to ChatGPT to figure it out. Okay, so show me a hello world example of uh, training a polynomial model using scalar with a 2-degree. I just want to remember that input statement. Okay. Yeah, so these are the things I'm looking for. So we need some of this. Get an import. So this is polynomial feature pipeline. These are the things you need to train a the curve. Okay, polynomial model. And then the model you're gonna do is this. So I'm gonna put this together. Okay, that's the first model. I'm gonna do another model. I'll call it model two. All right, and this is gonna be 2-degree. Most of it you don't have to remember. Just then go search and find a reference. Okay, get a model ready, and the rest the same thing. So model two dot fit and input data and output data. All right, so here you got a model two, model two. All right, so same process. You can see that it's always fit and same input and output parameter. The only difference is that the model you form is different. This is linear. This is some kind of a special model, which is the polynomial model. Okay, so let's try this again. I'm going to use a prediction result again. So this time I got a 2, 2, and model 2. I predict exact same thing. And then now let's check the difference between the results, right? So the first model here, I'll make a comment. Okay, and here is the second model. All right, so let's run this. As you can see, the results are quite different. The first one, the same thing, the best fitting is almost like a flat line, and this one is more accurate. So 10 o'clock is 7, 8:30 was 8, was pretty high, but then see 12 o'clock and 3 p.m. it goes down. It goes down dramatically. All right. At least you can see that curve happens. Okay. At least for the 12 o'clock, that makes more sense, right? 12 o'clock should be somewhere here. And then 1 o'clock, 1 p.m., 2 p.m., 3 p.m., 3 p.m. probably somewhere here. That's why it goes to the negative 17. As you can see, this polynomial model clearly shows the the trend. All right. So that shows us if you want to make a good machine learning problem, you really need to get everything right. Okay. Data should be enough because if you don't have enough data, you can't see this clearly. You don't know the pattern. And then if you know the pattern, you got to choose the right model to train it. That will give you a better results. Okay. And then there's one more thing is that sometimes the model, the feature should be right because in this case, we are only talking about a very simple case that we look at the time. But let's say the time like this one, okay? Um, this is more common for a weekday like today. Okay, so it's a Thursday. So if you want to make the model more accurate, you might want to say something like this. Okay, for Thursday data, it's probably something like this. But if it's a weekend, okay, if this one is Saturday, I think this is going to be quite different. 6 p.m., 6 a.m., nobody's getting up. So this one going to be 1. Okay, 7 still very light traffic. This is all very light traffic probably. And the really traffic started to pick up maybe around 11 or 12. So I'll put this one as 7, 8, right? So as you're involving more features, you also need to provide more data to show the difference. If there's no difference, then that means this feature is not valid. Then you don't need that feature. But if there is a difference, then you gotta show the data to show it. So if I want to add that feature here, I gotta provide this. So for the Thursday data, it's like this. So I'm gonna copy it and put this one here. Okay, Thursday data, that's a linear trend and with a curve. So when you are making the prediction, you often need to see the date as well, because that's what your input model requires you provide. Now you have two input features. Okay, if you do this, you run the results, it should be the same thing. Okay, there's no difference. But then different happens that when you are providing another set of data. So for example, I'm also going to tell you the Saturday data. Okay, so Saturday data should be very different. As I mentioned earlier, this one could be 1, 2, 3, 4, and then 6, 8, 9. Okay, so this is a little bit more linear. Okay, but then they increase it from the different time step. So I provide two situations and then two results. So if you only try to predict the for Thursday, that result should be similar. But if you are also predicting the Saturday, so you're gonna change this one and the same here, so we can compare. All right, so they give you different things. All right. Now, as you may see that, so for the second row that represents Saturday data, and then the first one, the Thursday data, you can see even using the same model, it gave you different results because the model is trying to pick up this new feature here, and based on the new input data you provided, they will be able to feed that model in and then give you results, right? So I think in this case, you can see the linear model works better for this one actually is more accurate for the linear model. And oh, sorry, so this one also pretty good. But overall, what I'm trying to show you from this example is that when you are trying to solve a machine learning problem, a lot of factors are going to affect results. Data set is so important. Okay. If you don't have enough data, if you don't have enough features, that's not going to work. Okay. And then the model you choose also affect it. Okay. When you see the data set, it includes not only the size, but also the feature set. Okay. Both things. Okay. You got to have enough data, but also you need to give me the right features to describe the whole problem. Once you know those, you can determine a good model, and then you can run it, and then you can see how the result is. All right, so that is a very quick and simple Hello World machine learning problem. I think that's the probably the easiest problem I can ever come up with. I think this one is very useful for you to understand it if this is the first time you ever touch machine learning. Okay, if you want to learn more about machine learning, the best course is this machine learning course from Kasar. Okay. From Andrew Wynn, I think that one. It's a very famous course. It's let me find which one. Uh, yeah, it should be this one. Okay, so that one from Andrew Wynn. So this is the guy from. It used to be from Stanford, but now he's doing startups. Okay, so yeah, that's what we want to cover today, guys. Just want to give you some kind of ideas, and then next time I will show you another type of very common machine learning problem, which might be related with the large language model, and then from there, you can start to play around with it and see how you can train a kind of a language model based on this. All right. So, any questions so far? Yeah, next we will come back in person.